Hello, this is a demonstration video of a calculation tool that I developed some years ago to be used in the teaching classes about thermal comfort. This tool we are calculating the PMV, the predicted mean vote, and PPD, the predicted percentage of dissatisfied. These are two indices that were developed by Professor Olefanger during his PhD thesis conducted in the Technical University of Denmark in the 1970s. And this was adopted as an evaluation method by the ISO 7730 standard. And it's one of the most used ways of evaluating thermal comfort. In this method, we should do an iterative calculation to obtain the value of the external temperature of clothing, and that's why we need to have a computational tool to apply it. So in this tool, we have here on the left side the introduction of the input data, the metabolic rate, the external work, the insulation coefficient of the clothing, the air temperature, the mean radiant temperature, the partial vapor pressure in Pascal, and the relative air velocity between the human body and the air. Next, we have the calculation of, let us say, these three input values in the SI units instead of using the units that were introduced by Fanger in his method. And here we have the control of the iterative method. So the calculation is considered finalized in case the difference between the value of the temperature of clothing that we have displayed here and our initial guess for it is 0. There is a hidden cell here where the written value is in the same color as the background, and it's the cell where we have the first guess of this initial temperature. Once we change any one of the values here in the inputs, for instance, let us say I will increase the value of the metabolic rate to 1.44, and so you see that this difference is no longer 0, which means that I need to apply again the iterative process, and this will happen in case I'm pressing this run button. That you see now it was recalculated the value for this new input value. So here in the middle section we have the intermediate calculations for the application of the method. We start by calculating the external temperature of the clothing, by calculating the heat transfer coefficient by convection. We are doing two calculations. We are calculating the natural convection coefficient, which depends on the temperature difference between the external temperature of the clothing and the air, and the forced convection coefficient that is dependent on the air velocity. And basically we are taking the maximum of those two, meaning that, for instance, in this situation, because the velocity was relatively low, the natural convection coefficient is the one dominating the phenomenon. We are also calculating FCL, so the correction factor, to take into account the relationship between the naked and the other parts of the human body that are covered by clothing. And in this case, we take the minimum. Once we apply the iterative method and we know the external temperature of the clothing, we are in conditions of calculating all the heat fluxes released by the human body. So we have perspiration, sweating, the breathing latent part, and breathing the sensible part, and finally the dominant ones usually are radiation and convection. The sum of these, all those heat fluxes, is this value that we have here as the total flux, and basically here we are subtracting the heat generation that we have here, this value 81.4 minus this 77.17, and this gives us a positive balance. It means that for this situation, the human body was generating more heat than what it would be losing, which means that some heat would be stored in the human body, meaning that this person will feel a little bit warm. So, and in the fungus equation, once we calculate this, after we apply let us say, the model for the human perception that transforms this heat balance into the vote in the PMV scale, ranging from -3 to +3, and where 0 corresponds to the neutrality and thus to the comfortable situation. In fungus method, there is also an equation allowing us to calculate, based on the PMV value, how much would be the percentage of dissatisfied people. And in this case, we are calculating 5.7, which means that we are quite close to the best situation, because it's not possible to have a percentage of dissatisfied lower than 5%, because even for the situation that satisfies most of people, there are like some fringes of people feeling either cold, either warm. So this is the result of the calculation for the situation I was showing. In this Excel file, we have also the possibility of having the graphical representation of the different terms in the equation. So here we have the generation of heat in the body, the sum of all the heat fluxes, and here the breakdown of the considered heat fluxes. There is also the possibility of showing this type of graphs with, let us say, the breakdown of in this cheese type graph with the different coefficients, the different heat fluxes, and finally the breakdown between latent heat and sensible heat for the situation that we were showing. Besides this spreadsheet that I was showing, there is like a second one. It's this one that I'm showing now. The only difference is that instead of having as an input value the partial vapor pressure, that we may say it's not the type of value that we are getting directly from the measuring equipment. We have the possibility of doing the calculation based on the air temperature and the relative humidity. So with the air temperature value and the relative humidity, we can calculate the vapor pressure, the partial vapor pressure, and proceed with the calculations once we have these values. And okay, we have also here the same type of representations that I was showing for in the previous spreadsheet. And that's all regarding this tool that I developed to be used in my classes in the course about indoor environmental quality in the model dealing with thermal comfort. Thank you very much for your attention.